Problem 9. Calculate the unit cell edge length for an 85 weight percent ferrous, 15 weight percent vanadium alloy. All the vanadium is in solid solution, and at room temperature the crystal structure for this alloy is PCC. So we have to find the unit cell edge length. So for BCC we know that the unit cell edge length is represented by A. This we have to find, but how we can find it? If we know that if we relate it with the data given, so concentrations, weight concentrations are given. C1 is equal to 85, C2 is given as 15%, and we know that the average, that means from these weight concentrations we can find their average density. We can find the average density by this 100 divided by 85 divided by the density of iron. The density of iron is density of iron is 7.87. Okay, density of iron is 7.87 gram per cubic centimeter. Density of vanadium is 6.1 gram per cubic centimeter. So 85 divided by the density is 7.87, and then 15 divided by this density is 6.1. So in this way we will get the average of 7.56. The density is 6.19. Okay, so here we will get 7.56 gram per cubic centimeter. Okay, so well, we have found it, but how are we going to use it and then to find this value of A? If we recall that the average density of a composite or any metal, we can relate it by this formula: Na divided by Vc times Na, where A is the atomic weight. So if we are taking the average density, we can take as the average atomic weight as well, and N is the number of atoms in BCC. Okay, the number of atoms inside of the unit cell of BCC, and Vc is the volume of the unit cell. So volume of the unit cell is related with E, because A cube, because it's a cubic cell, is equal to Vc, and N value is equal to 2, because we know that there are 8 corner atoms. Each corner atom is 1/8, and there is one central atom, so N will be equal to 2. So what is left is the average atomic weight. So average atomic weight in a similar way can be found from the weight concentrations. Average atomic weight 100 divided by 85 divided by the atomic weight of iron. So the atomic weight of iron is 55.85 gram per mole, or the atomic weight of vanadium is 50.94 gram per mole. So 85 divided by 55.85 plus 15 divided by 50.94, so this will be 55.05 gram per mole. Now we have everything in this expression. Rho average 7.56, N is 2, A average is 55.05, and divided by Vc is A cube. And what is Na? Na is the Avogadro's number. Okay, so Avogadro's number. So 6.022 into 10 to the power 23. So you can rearrange this equation and solve it for A. So A will be 2.89 into 10 to the power minus 8 centimeter, because the units were in cubic centimeter for the density. So the value of A will be in centimeter, and then we can multiply it with 10 to the power 7 to convert it into nanometers. So it will be 0.289 nanometer. So this is the unit cell edge length for this question.